Hey guys, so this is chapter 11, section 3, area of regular polygons. So if you look at this particular shape here, we have a hexagon that's inscribed inside of a circle. So remember, for something to be inscribed, the vertices of this particular polygon hexagon has to be touching the edge of the circle. We have the center of the circle, which is also the center of the hexagon P. And if I go out from P to M, that's the radius of the circle. If I go out to P to N, that's also the radius of the circle, and can also be called the radius of the hexagon. So we would call PM the radius for the hexagon, and we would call PN also the radius for the hexagon. We have segment PQ, which is called the apothem. Which refers to the line that goes from the center out to the side of this particular hexagon. This apothem is the perpendicular bisector of this hexagon. Perpendicular bisector, meaning that it's going to cut the angle in half. Angle P is cut in half, and MPQ is equal to NPQ. M as in Mary, N as in not today. And then it also cuts the side in half. MN, side MN, MQ is congruent to MN, so they're cuts it in half. So perpendicular bisector. This hexagon is a regular hexagon. And a regular hexagon, or any regular polygon, means that all the sides are the same. So we have side MN, and all its other 5 sides are congruent, and the angles within it is also the same. So angle M and angle N are congruent, and all the other 4 angles are also congruent in this regular polygon. So down here, we have a square circumscribed, inscribed inside of a circle. They want us to find the center, the radius, an apothem, and the central angle. All right, so the center of this square is P. The center of this square is P, and the radius goes from the center to the end of the circle and also to the vertex. So XP is the radius, and YP is the radius. The apothem goes from the center to the side, and remember, it cuts it in half. So the apothem is PQ. The apothem is PQ, and it cuts XQ and YQ in half. So the center is P. The radii, I think that's how you spell it. I don't know. Radii. Let's go with what I know. Radius is XP and YP. It is called radii, but I don't remember how to spell it. The apothem is PQ. And the apothem cuts the side in half. So we can say, and this isn't in the question that they asked, but we can say that XQ is congruent or equal to YQ. We can also say, since it's a perpendicular bisector, angle XPY, which is the central angle because it's from the center, from the middle of the circle and the square. XPY can be cut in half, so we can say that angle XPQ is congruent or equal to angle YPQ because it's a perpendicular bisector. Lastly, they ask about the measurement of the central angle. So we know that one revolution around this angle P is 360 degrees. We divide that revolution by the number of sides. In this case, for a square, it's 4. So the central angle, and this is going to be angle XPY is equal to 90 degrees. That is our central angle. Okay. Oh, they want us to find all of the angles. Okay, so if XPY is equal to 90 degrees, then I know that angle XPQ is equal to angle YPQ, because it's an angle bisector, it cuts it in half. So that's going to be 90 over 2, or these guys are going to be each 45 degrees. And that's important when we find out how to solve for the area of these regular polygons in a moment. Okay. Next page. How do I find area? So, if we look at this here, we have this regular polygon that we can cut into many, many triangles. This looks like a 1, 2. This looks like it's a hexagon. So we have that triangle, which is one of many triangles within this particular polygon. We have the apothem, and it's going to be perpendicular, and it's going to cut that in half. And then we have the side. We know that an area of a triangle is equal to 1/2 the base times the height. Well, in essence, that's what you're doing here, but instead of calling it base times height, we're calling it apothem and side. So an area of one of these triangles inside your polygon is equal to the apothem, which is the height, times the side, which is the base. That's only for one triangle, but we have, in this case, looks like a hexagon. We have 6 of these triangles. So what we do is we find out what the perimeter is. And the perimeter is just multiplying the number of sides, in this case of the hexagon we have 6, times the length of the side, and that will give us our perimeter. So if I want to find the area of the whole entire regular polygon, as opposed to not just one triangle, you multiply the apothem times 1/2 times the perimeter, and that's going to give us our area. That is the equation for area of a regular polygon. The apothem times the perimeter times 1/2. I think the book also says 1/2 a times the number of sides times side. Nobody really uses that. They usually just do apothem times the perimeter. Okay. So what does one of these problems look like? We have 3 of them, and there's going to be 3 ways to solve them, and the book gives a synopsis of it down here. You can use the Pythagorean theorem, you can use special right triangles, and we can use trigonometry. Trigonometry is sine, cosine, tangent. Special right triangles is 30, 60, 90 triangles, or 45, 45, 90 triangles. And then you better know what the Pythagorean theorem is. A squared, B squared, and C squared. So for number 3, they give me a pentagon. They give me this pentagon. Anyway, and the pentagon has 5 sides. So I'll try my best to draw a pentagon, but you guys know that my best when it comes to drawing sometimes just is not good enough. Alright, my version of a pentagon. We have it from the center down. This is 6.5. And then we have an 8 over here. So if I was to, and it's going to be a right triangle. If I was to sort of complete this line here, remember that this is the side, right? The whole thing is the side. But when I cut these triangles in half with the apothem, this guy is half of one side. Half of one side. So if I blow up this triangle a little bit over here, we have a hypotenuse of 8. We have one of the legs of 6.5. And then we have half of a side. So we can use the Pythagorean theorem to solve this. In this case, it's going to be c squared minus a squared will give me ib squared. And then we're going to square root that. So in this case, it's going to be 8 squared minus 6.5 squared. And that's going to give me my b squared. Now we're going to square root it. So eight squared minus 6.5 squared gives me 21.75, and we're going to square root that. And that gives me a very long number, 4.664. 4.664. And after we do that, we know that that's half of the side. So half of the side equals 4.664. So we just multiply it by 2 to get the whole side. Therefore, the side is equal to double of that, which is 9.3. We'll say 33. 9.33. So the side is equal to 9.33. So what did that question the book asked us to find? The book wants us to first find the perimeter. Well, now that we know that we have a pentagon, so we know that there's 5 sides, we can find the perimeter. Perimeter is equal to the number of sides times the side itself. In this case, we have 5 sides, and we know now that the side is 9.33. So we know that the perimeter is equal to 46.64. Remember what I told you guys about not rounding until the very end? That still holds true. I'm just rounding here because I don't feel like writing all those numbers down infinitely many times. Now that we got the perimeter, they want us to find the area. Remember, the area is equal to 1/2 the apothem times the perimeter. So the apothem is 6.5, and the perimeter is 46.464. That gives me an area of 151.6 approximately. And I got 151.6 units squared. Remember that we're finding the area, so your units will always be squared. Alright, so what did I do? Well, first thing I did was I set up my triangle within the pentagon, this horribly drawn pentagon. I noticed that when I blow up this half of a triangle, the hypotenuse is 8, one of the legs is 6.5, so it's up to me to find the side, half of the side. So I used the Pythagorean theorem, and I knew that 8 was hypotenuse, so I subtracted 8 squared minus 6.5 squared and square rooted that, and it got me half of the side, which was like 4.6 something, and then I doubled that to get the total side of 9.33. Then I multiplied that 9.33 times 5, because there's 5 sides in a pentagon to get the perimeter, which is 46.64. Then I plugged that in into my area of a regular polygon equation, 6.5, the apothem, times the perimeter, 6.64, times 1 half, which gave me an area of 151.6 units squared. Number 4, they ask us to find the area of this particular regular polygon, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a decagon, meaning it has 10 sides. I already know what the side is, so I have a perimeter is equal to the number of sides times s. In this case, it's 10 sides times a side, which is 7. So the perimeter is 70. Nice. Next thing they want us to do is to find an area. I guess I gotta write 70 units because they don't give me a number. Alright, 70 units. In order for me to find the area, I first need to find the apothem. I already have the side. So the first thing to do is to find the central angle. So my triangle for one of these triangles for this is going to look like this. I want to find this apothem. This is what I'm looking for. I know that the side is this, so I have to find this guy. And I find this guy by first dividing 360 divided by 10. That gives me the degree of the central angle, which is 36. But I need half of that because I'm going to cut this triangle in half so I can use actually no I don't. Alright, so I'm going to divide this in half, so this is going to be 18. So now I have an 18 right here. This is 18. I'm going to cut this 7 in half because I know this is a bisector, so this is going to be 3.5. And I have an angle of 18 degrees, and I'm looking for the apothem. So I have 3.5, which is opposite of 18, and I have the apothem, which is adjacent to 18. So that means that I'm dealing with tangent. So tangent of 18 is equal to opposite over adjacent, which is in this case 3.5 over the apothem. I'm going to multiply both sides by the apothem and then divide both sides by tangent of 18, and I get 3.5 divided by tangent of 18 is going to give me my apothem. In this case, it's going to be 10.772 units. 10.772 units. Okay, so now we have our apothem. We have our side. So we have enough information to find the area. Area is equal to 1/2 the apothem times the perimeter, which is in this case is 1/2 of 10.772 times 70. which gives me about 377 units squared. So for this problem, we first had to find the perimeter, which was just to multiply 7 times 10 to get 70 units. Then I found the central angle by dividing 360 divided by 10, which gave me 36. Then I divided it by 2 because the apothem cuts the angle in half. I also divided 7 divided by 2 to get 3.5. Since we cut the triangle in half, we cut the side in half, we cut the angle in half. Then I used trigonometric ratios. I knew that the half of the side was opposite of the 18 degrees, and I knew that the apothem was adjacent to 18 degrees, so I did tangent of 18 degrees is equal to 3.5 over the adjacent side, and I did some algebra, and I got that the apothem was 10.772. Then I plugged that into my area equation, and I got that the area was 377 units squared. Right. The last one here, number 5, we have a triangle that's inscribed. They give us the apothem this time, so that's neat. The apothem is, hey, I can draw a triangle, y'all. It's that. Remember that we're dealing with a regular polygon, so this is a regular triangle, which means that all the angles are the same, so I know that all the angles are 60 degrees. So I was first thing I'm going to do is find the central angle. 360 divided by, there's 3 sides, so that makes it 120. And since it's 120, I know that I have to divide that by 2 to get half of this angle here, right? And that's going to be 60 degrees. So this guy here is 60. This guy here is 60 degrees. Which means that this would be 90, right? And this means that this is 30. So what do we have here, guys? We have a 30, 60, 90 triangle. And if you remember, we have 2 equations associated with that. The hypotenuse is equal to the short leg times the square root of 3. And we also have, times 2, I'm sorry. And the longer leg is equal to the shorter leg times the square root of 3. In this case, we have the apothem, which is the short leg, and we're looking for, in this case, this is going to be half of our side, right? This is half of our side. So half of our side, this is the longer leg because the hypotenuse is opposite of the 90-degree angle. So we're going to use this equation down here. So we can say that half of side, which is my longer leg, is equal to the short leg, which is 5 times the square root of 3. So if half the side is equal to 5 root 3, then the whole entire side is double that, which is 10 times the square root of 3. So now we have our side. Now we have our apothem that's already given to us. We have enough information to find the perimeter, and we have enough information to find the area. So apothem is equal to 5. The side is equal to 10 times the square root of 3. Perimeter is equal to the number of side times the side. In this case, it's going to be 3 times 10 root 3, which means that our perimeter is 30 root 3. That is our perimeter. And then our area is equal to 1/2 of the apothem times the perimeter, which means that it's 1/2 of 5 times 30 root 3, which is 1/2 of 150, so 75 root 3, which is about 129.9 units squared. Okay, and that is our area. So our area is 129.9 units squared, and our perimeter is 30 root 3. The last one, number 6, they ask you which one of these can be solved using special right triangles. That was number 5. And here is the thing about that. So triangles had 3 sides, right? Hexagon has 6 sides. And then squares and rectangles have 4 sides. If it's a triangle, you're going to use 30, 60, 90. If you have a hexagon, you're going to use 30, 60, 90. This isn't in your book. If you have squares and rectangles, you're going to use 45, 45, 90, 45, 45, 90. 3, 6, and 4. Triangles, hexagons, squares, and rectangles, you're going to use 45, 45, 90. Maybe some rhombuses. So to refresh your memory about a 45, 45, 90, if it's a 45, 45, 90, then your legs are the same. We're dealing with an isosceles triangle. And then you have your hypotenuse. Your hypotenuse in a 45, 45, 90 is only one equation. It's equal to x times the square root of 2. That is your 45, 45, 90 equation for a special right triangle. So again, they give you this synopsis down here. You can solve for the regular polygon area by using either the Pythagorean theorem, special right triangles, which is 45, 45, 90, or 30, 60, 90 triangles, or trig ratios, sine, cosine, tangent. And that is 11.3. Have an excellent rest of your day.